Okay, so we will start today to do review problems on the part you are responsible for the exam on moment and forces. So to start with, determine the resultant moment produced by forces Fb and Fc about point O and express the result as a Cartesian vector. So here in this problem, we have two forces, Fb and Fc, and we want to determine the resultant moment about O. Okay? So, as I told you, whenever you have a 3D problem, the easiest way to get the moment vector is to do the vectorial product. So, what I can say here, I can say that the resulting moment about O is simply equal to the moment of Fc about O plus the moment of Fb about O. Now, this can be written as first for FC is passing by A and C. So you can take or OA vectorial FC or OC vectorial FC. But of course, as you can see, A is easier because A has only coordinate along Z. Plus, A is common between the two forces. So here, it will be an advantage to take A because we will take OA into factor between the two. So I will write that for FC, it's OA vectorial FC plus for FB, the moment about O is OA vectorial FB. And here, since I have OA in common between the two, so I will take OA into factor. So it's OA vectorial FC plus FB. Okay, so now all I have to do is to do the vectorial product. Okay, I can do the expansion, the simple expansion, or the matrix. Here the simple expansion is easier because what is vector OA? OA has only a component along K, so it is equal to 6K vectorial. Now, for FC, we know the magnitude, and we should know the find the direction through the unit vector. Okay, so we can write that FC is equal to 420 times unit vector of AC plus for FB it is 780 times unit vector of AB. Okay, and now in order to complete the problem, all I have to do is to find coordinates of points A, B, and C, to find unit vector of AC and unit vector of AB. So as you can see here in the figure, for point A, it is 0, 0, 6. For point B, I have as coordinate 0, 2.5. It has only a coordinate along Y. So, for example, this type of problem can be given in the exam. It's not a very long question, okay? And for C, I have along X it is plus 2, along Y it is plus 3, and it is 0 along Z. So 2, 3, 0. Now, once I get coordinates of the 3 points, all I have to do now is simple replacement. So I start first by getting force Fb. I know that Fb is the magnitude of Fb times, uh, I consider now for Fb vector UAB. So I take Xb minus Xai plus Yb minus Yaj plus Zb minus Zak. And I divide, of course, by radical of 0 square plus 2.5 square plus 6 square. I get my vector FB. I do the same for unit vector of AC to get it. And once I have the expression of the two forces, okay, now here what they did, they used the matrix form and they didn't take OA into factor, so it is longer for them to do the calculation. If you paid attention that OA is common, this will it will simplify the calculation. So you will just say it's equal to 0.6k vectorial. If you do the summation of FB and FC, what do you have? Along I, you have 120 plus 0, so it's 120I, plus along J, no component, it's 300 minus 180, so it's plus 120J. And along K, if you do the summation, it's minus 1080K. So now, instead of doing the matrix, which is a little bit longer, all you have to do, you can do the expansion here. So K vectorial I, you go to your circle, K, I, J, it's turning in the positive direction. K vectorial I is plus J. So here I have plus 0.6 times 120 along I. Sorry, it's not 0.6, it's 6 because it's 6k. OA is 6k. So 6 times 120 is 720. So it's 720J. Now, along the second component, K vectorial J is opposite to JK, so it's negative. It's minus 6 times 120 I, so it's minus 720 I, and K vectorial K is 0, so I end up with the final result. And as you can see, I obtain the same result, but in a much faster way. Instead of doing the matrix 1 plus matrix 2, so this is much easier here. So always try to choose a method which will simplify your calculation. Any question on this problem?
Doctor,
Yes.
when do you advise us to use the matrix, but
I
then
advise you to
the
use
other
the
method?
matrix if you don't have a lot of zeros. So here you have a lot of zeros. 0, 0, 6. So here if you do the expansion, the development, you have only two terms to do because K vectorial K is 0. So here it's much easier to do the direct expansion. But if you have, for example, instead of 0 here, 1 and 2, then it will be hard to expand. You will have to do several calculations. So in this case, use the matrix. That's it. Because when you have a lot of numbers, the matrix will simplify calculation. When you have a lot of zeros, the expansion will be easy. But in all cases, both will give you, of course, the same result. Okay?
Okay, thank you, doctor.
Okay, another problem. Determine the resultant couple moment of the two couples that act on the pipe system, and the distance from A to B is 400 millimeter. Express your result as a Cartesian vector. Please, in the exam, pay attention for that why they want from you. Sometimes they just ask, find the magnitude, for example, of the moment. So first you find the moment vector, then you calculate its magnitude and you put it in your box. Here, for example, they ask for the vector. So your final answer will be in a vector form. Okay? Now, in this problem, I want to find the resultant couple moment. So here, as you can see in the figure, I have two couples. This is little bit close to the example we have solved together in the last time. So I have first this couple of two forces. Who can tell me for this couple, the moment produced will be along which direction?
X.
Exactly, it's about x. Why? Because these two forces are in a plane parallel to yz, so they can only produce a moment about x. So here, instead of doing the vectorial product, I have an easier way, which is to do the right-hand rule, because I know that my couple is only about x. If you do the right-hand rule, it will be along positive x or negative x.
Negative x.
Exactly, negative x. Why? Because I put the four fingers along the first vector, and my palm is directed towards the second vector. So if I do this, my thumb will point in the negative x direction. Okay? So I can be sure that my moment is negative along x. And what about the magnitude? What is the magnitude of my moment?
The distance time 35.
Okay, what is the distance here, the perpendicular distance between the two? Is it this distance here?
No, we need to multiply it by cosine 30.
Very good. We should draw the perpendicular. So this is the line of action of the force. I can extend it. I draw from A the perpendicular to it. And this will be the perpendicular distance. It's d cosine 30. So I can say that the moment of first couple, moment of couple 1, is equal to minus 35 times d times cosine of 30. And d is given, it's 400 millimeter. So I can just replace d by 0.4. Now, if I didn't pay attention to use right-hand rule method, I can use simply the vectorial method. Okay? If I want to use here the vectorial method, what can I do? Which vectors I will choose?
We choose vector AB.
Okay, if I choose vector AB, I do vectorial what?
Vectorial 35k.
Exactly. If I choose plus AB, I do vectorial plus 35k. If I select vector BA, then I do BA vectorial minus 35k, and both will give me, of course, the same result. So let us check.
Doctor,
Yes.
here the minus in 35 in MC1 because it's clockwise.
Because from the right hand, look, in 3D, we don't talk about clockwise and counterclockwise. We talk about clockwise and counterclockwise in 2D. In 3D, we do the right hand rule. And as you can see here, the thumb will point in negative X direction. So it's a negative moment along R.
Okay, so in this method, when I put minus, it's only from the right-hand rule.
Yes, exactly. It's only from the right hand rule. Okay. Now, concerning the vectorial method, let us check. We'll get the same result. So it's AB vectorial 35k. Now, what is AB vector? AB vector has two components. It can be divided into a component along J in the negative direction and a component along Z in the positive direction. So I have that it is equal to, first it is it's minus 0.4 cosine 30 along J plus 0.4 sine 30 along K vectorial 35k vectorial 35k. So let us verify that we'll get the same result. It's equal to, first, J vectorial k is plus I, and I already have a minus, so it's minus 0.4 cosine of 30 times 35, and k vectorial k is 0, so I just have the component along I. Okay, So from here, you can see that I obtained the same result. But here, the first method is faster, for example. Okay? Now, the second couple I will consider. So this is the first couple. I should add to it the second couple. The second couple is the 50 Newton couple. Okay? So here I have this force and this one. Now, these two forces are in an inclined plane. So, of course, their moment will have several components. It will have a component along which directions? Who will tell me? They will produce a moment about X, these two forces.
Yes.
About X. Look, they are parallel to X. If they are parallel to X, they cannot produce moment about X. They will have a resultant moment about Y and a resultant moment about Z. So I can verify after that I will get only J and K components. Why not I component? Because already the forces are parallel to I, so they cannot produce moment about I. Okay? Now, here, since it's little bit more complex, so it's easier to do the vectorial method. I will do for you both, but the vectorial is easier. So here, since I have these two forces, okay, look, whenever I have a force, I can displace it on its line of action without varying its moment about any point in space. So the 50 Newton, it's here. You can place it here. It will still produce the same effect. Okay? So here, to find the moment of your couple, you have two possibilities. Or you can take the same vector. So you take AB vectorial minus 50i, or also you can take AC vectorial minus 50i. The two will give you the same result, because if you remember, we said we can take any point on the line of action of the force, okay? And even a force can be displaced on its line of action without affecting its moment about any point in the space, because when you displace it on its line of action, okay, you will not change the perpendicular distance to any point. So if I want to use the vectorial method, I can say that the moment coupled to can be written as or AC vectorial minus 50i, or since we have already calculated AB, it's easier to work with AB. So let us say that it's equal to AB vectorial minus 50i. And now I replace AB vector by its components. So it's minus 0.4.
Doctor, why is it still minus 50i?
Because look, when you go from A to B, you should take which force? This one, okay? Which is what? Which is minus 50i. If you did BA, so if you go from B to A, then you take the second force, so you do BA vectorial 50i, okay? Since we selected AB, so when you do AB, it's vectorial minus 50i. Okay?
Okay, thank you, doctor.
So it's minus 0.4 cosine 30 along J and plus 0.4 sine 30 along K vectorial minus 50i. Okay. Here, for example, also to do the vectorial product, it's easier to do the expansion since I don't have a lot of terms. Okay. So I will start first by J vectorial I. J vectorial I is minus K. Okay. But I already have minus minus plus, so it's minus in total. So I have minus 0.4 cosine 30 times 50 along K. And the second term, K vectorial I is ij, Ki is plus. Okay, Ki is plus J, but I have a minus, so it's minus 50 it's minus 0.4 sine 30 times 50 along J. So as you can see, as expected, the resulting moment MC2 will have a component along K and a component along J, but no components along I. Now, if I want to use the previous method using the right-hand rule without the need to do vectorial product, what should I do? It's a little bit more complex because here I have components about several axes. So what I can say, if I want to do the method, I can say that for this couple, I will divide the moment of the couple into three components. Moment of couple 2 along X, it's of course 0. Why? Because my forces are parallel to X. Okay. Now, if you want to find the resulting moment of this couple about Y, MC2Y, okay? It is the summation of moment of the forces about Y. So if you look at your figure, this force of 50I is passing by Y-axis. So it cannot produce a moment about Y. But the second force can produce a moment. So this force here, the minus 50I, will have a moment about Y. Now, how to determine its moment about Y? I look at the perpendicular projection between the two. Perpendicular distance between the two is this one, okay? Which is equal to what? It's equal to this distance, which is 0.4 sine 30, okay? And in order to know if it's a positive or negative moment, I do the right-hand rule. So I put my 4 fingers along the force. My palm is towards y-axis, okay? So my thumb will point in this direction. So this means that I have a negative moment about y. So I can simply say that MC2y is equal to minus 50 times the distance between the two axes, between the force, sorry, and y, which is 0.4 sine 30. And you can verify that I got the same result because here along J, what do I have? Minus 0.4 sine 30 times 50. Exactly same result. Now, along Z, the moment of couple along Z is equal to, I can also say that for the first force plus 50I, it's passing by Z axis, so no moment. So I will have only the moment of this force about Z, okay? So to get the moment of this force about Z, I should know what is the distance between them. So the distance between them here is, if I draw the perpendicular, it will be this distance because it is the distance from the axis to the plane containing this force. And this distance is 0.4 cosine 30. Now, I still just need to know, to do the right-hand rule, to know if it's a positive or negative moment. So always same method. I put my 4 fingers. Now my palm will be looking at the axis, okay? So here, if you want in 3D, you should try to imagine it a little bit, okay? So if I do it, if I put my 4 fingers like this, facing the axis, okay? Then my thumb will point vertically downward. And in this case, I have a negative moment about Z. So I will write now, it is equal to minus 50 times 0.4 cosine 30. So I got also the same result. Here along K, I have minus 0.4 cosine 30 times 50. But of course, again here, what is easier is the first method, the vectorial one. So what I advise you to do, if the couple is very simple and it has only component along one axis, the right-hand rule is easier. In case it's not, in case I have several components, it's easier to do the vectorial method. Okay.
Doctor?
No, yeah, just 1 second. Michael, no, it's not the couple, the first one, it's not an inclined plane because look, the first couple to 35, look, 35, the 35 forces are in a plane parallel to YZ. And YZ, it's not an inclined plane, okay? Since you have this plane parallel to YZ, then it can only, these forces can only produce a moment about the axis that is perpendicular to YZ, which is x-axis. So it's not an inclined plane. On the other hand, if you draw the plane of the 50 Newton forces, it is like this. It will be a plane like this. So it's not parallel to YZ, it's not parallel to XZ, it's not parallel to any known plane. Okay? This is called an inclined plane.
But doctor, isn't it parallel to the x-axis?
Yes, it's parallel to the x-axis, but not to a plane. Okay? يعني it should be to say that it's an inclined plane. It should not be parallel, for example, to XY plane or to YZ plane or to XZ plane. It's if it's only parallel to X, then it will have a unit vector. So try to draw the normal vector. If you draw the normal vector to this plane, it will have two components, in Y and in Z. So this is why we say it's an inclined plane, because its normal vector, it's not in X or Y or Z, okay? While if you take the first couple of 35, the normal vector is along what? Is along X, okay? Why it's along X? Because already the two forces are in plane YZ, in a plane parallel to YZ. So when I say it's an inclined plane, this means that its normal vector has more than one component. Is it clear now? Or do you want me to repeat this idea? Okay. So any question on this problem before we continue?
Yes, doctor.
Yes.
When I wanted to calculate the moment about y,
Yes.
I put the right-hand rule
Yes.
and for the 50 Newton force, the
Yes.
right-hand rule, I put my pole
Yes.
parallel to Z and
No, look,
I got
I put my fingers parallel to the 50 Newton force, so parallel to X, okay? And my palm is uh, is looking at Y axis, okay? So my palm should be in which plane? My palm should be in Y, in a plane parallel to Y axis. So try to do it. Look, your fingers will be along the force, and your palm is in a plane parallel to Y axis, like this. So this is Y direction, this is X direction, so your palm is like this. So this is your four fingers. Okay? And my palm is looking towards Y. So now your thumb will point in which direction in this case? Like this. Your thumb will point in the negative Y direction. Did you try to do it?
yes, doctor.
Okay. While for the when you do moment about Z, your palm will be in which plane? Your palm will be in a plane parallel to the axis. Okay. So in this case, when you put your four fingers, it will be like this. So the second scenario, okay, I want to find the moment of this force with respect to Z. Then I will put my four fingers in a way that my palm is parallel to the X plane now, and looking at the axis. Okay, so it will be like this. This is now my four fingers are like this in this position. Okay. So in a plane parallel to the X, like this, and then my thumb will point downward. Okay? So the whole idea is, depending on the axis, the plane in which my palm is will change. Okay? So when I want to calculate moment about Z and my force is along X, the palm of my hand should be along in the plane parallel to the axis. Okay.
Yes. Thank you.
Any other question?
Yes, Doctor, عندي سؤال صغير.
Yeah.
When we wrote MC2 in it, the moment of couple number 2 equals to AB
Yeah.
vectorial minus 50i.
Yeah.
How did we replace AB with 0.4 cosine 30 or minus 0.4 sine 30?
Okay. Because
I'm
AB.
sorry, these are new to me, but
No, it's fine. AB vector, you can decompose it into two components. This component along y, okay, and this is the component along z. If you look at your figure, you have this distance. D is given to be 0.4 meter or 400 millimeter. So the y component, first, as you can see, is negative, and in magnitude, in this right triangle, it's equal to the hypotenuse cosine 30. So it is equal to 0.4 cosine 30 in the negative y direction. Okay? Now concerning the component, it is positive, and the magnitude is equal to what? Also in this triangle, you have it's the hypotenuse times sine 30. Okay?
and there's no I component.
There is no I component because AB, okay, is perpendicular to X. It is in a plane. It is in which plane AB? In a plane parallel to Y and Z. Okay, as you can see, this line is parallel to Y. This line is parallel to Z. This means that AB will not have a component about X.
Okay, thank you, Doctor.
Right. Any other question on this? Okay. So let us continue. Just the final step to do is what? Because I want to find the resultant moment, I should add the first couple to the second one. Okay? So by just doing the summation here, I can get my resultant vector. So I sum I components to get here. It's straightforward because the first couple only has I component and the other one has only J and K. So the resulting couple will be minus 12.12I minus 10J minus 17.32K. And if I want to find the magnitude of the resulting moment, I do radical of 12.12 square plus 10 square plus 17.32 square. Okay, now another problem. Replace the force system acting on the truss by a resultant force and couple moment at point C. So here, this is an example about how we can reduce a system of forces into one force and moment at a certain point. So here, they asked us to replace the system at point C. Okay, just at point C. So, as we have seen in the course material, if I want to remove one force from one point to another, to have equivalent system, what should I do? I should add its moment about the point. Okay, so the first step to calculate the resultant force, all I have to do is to sum my forces. So here, let us consider a frame. If I take this is X and this is Y, for example, okay, then I can say that first, the resultant force along X will be equal to what? So F resultant along X is equal to what? Do we have X components here?
Yes.
We have only one X component for the final force here at point B. So at point B, I can divide the force into two components, one along X, one along Y. So as you can see, the component along X is positive, the component along Y is negative. So first, to get the component along X, I simply do the projection. And here, instead of giving me an angle, what did they give me? They gave me this here. This will help me to find my angle. Okay, so I am interested in this angle, which is equal to this one. So when I want to project on x, I should multiply by cosine of this angle. And cosine of this angle is equal to 4 over 5. Okay, so I can say that frx is, it's a positive component first, so it's plus 500 times cosine the angle, and cosine the angle is 4 over 5. So since I don't have any other component along x, this is the resultant along x. Now, along y, if I want to calculate Fry, I will do the summation of forces along y. So here I have several components. I have first minus 200, minus 150, minus 100, and finally the component of the force at B along y. So as you can see, the y component also is negative of this force. So I should multiply 500 minus 500 by sine of the angle. Sine of this angle here is 3 over 5. So it's minus 500 times 3 over 5. Okay, so in this way I can get the y components. So now, once I have the resultant x component and the resultant y component, I can say that in along C I will have the following. I have a positive resultant along x, a negative resultant along y, and now I can calculate the magnitude by doing radical of the two components square. And for the, if I want to determine the direction, I can find this angle here. How can I find it with x? I can say simply that theta is tangent minus 1 of, I will take, look, once you determine your quadrant, then you can take the absolute value for the tangent, because you want just to find the angle that is smaller than 90. So I will take absolute value of f resultant in y over f resultant in x. And then I can determine the direction of my force. Okay, so we are done with the first step. Now the next step is still to find what is the couple, what is the resulting couple at C. Okay, so I will open a new session to continue because this will end soon. Okay, just any question until here before we continue with the couple? Yes, Michael, why we elongate each line of action of the forces and do F times D? Oh, this is you mean for the previous problem, Michael? Yes, look, you elongate the line of action of the force because you want to find the perpendicular distance. Okay, so going back to the problem here. When you want to find the moment of a force about an axis, you need the perpendicular distance between them. So sometimes to just see where is the perpendicular distance, you can take the line of action of the force and say that the perpendicular distance to y-axis is this one. It's this one, and this one is equal to this distance, is equal to this distance. Okay, and this is the same what we are used to do for a point. So if you have the force here, for example, and the point is here, how you can find the distance? You extend the line of action of the force,